We now want to take a look at how to do unit conversions. So oftentimes we have a situation where we have a quantity measured in one unit and we need to change it to a different unit. So here's how we do it. We take the number that we want to convert and we multiply it by the appropriate conversion factor. And we set up that factor so that the units we don't want cancel out and the units we want are the only ones we're left with. Let me show you what I mean by that. So here's a very typical example. We want to know how many centimeters there are in 11 inches. The first thing we need is the conversion factor. So 1 inch is defined as 2.54 centimeters. Now, when we use a conversion factor, we're going to set it up as a ratio. So you can imagine there are two ways I could set that up as a ratio. I could either write 1 inch over 2.54 centimeters, or I could write 2.54 centimeters over 1 inch. In terms of which way I want to use it for a given problem, I have to just look at what it is I'm trying to accomplish. In this example, I have 11 inches. And what I want to end up with is centimeters. So what I do is I simply look at how should I put in the conversion factor. Should I put it in that way or that way? So that inches will cancel out and I'll be left with centimeters. Well, if inches is going to cancel out, it needs to be down on the bottom since it's up in the numerator here. So I have 2.54 centimeters over 1 inch. And I can see inches cancels with inches. And now I just multiply 11 times 2.54. If you do that on your calculator, you should get 27.9. And the only unit we're left with is centimeters, which is what we want. So that's how I would do that unit conversion. Let's look at a slightly more complicated example. If you understand this example, you really can convert any units that you need to. So it says you're driving your car at 60 miles per hour. How fast are you going in feet per second? And we've been given three different conversion factors. A mile is equal to 5,280 feet, an hour is equal to 60 minutes, and a minute is equal to 60 seconds. So here's how I'm going to set this up. I'm going to write that I have 60 miles per hour, and what I want to end up with is feet per second. So the first thing I want to do is I want to get rid of miles. So I got to put this into a ratio, and I can see that since I want to end up with feet, I need to have feet on the top and miles on the bottom. So that means I need 5,280 feet on the top and 1 mile on the bottom. So when I do that, you'll notice miles cancels with miles, and so it's good. I now have feet per hour, but what I want is feet per second. So to do that, I first have to get rid of hours. I can see that to get rid of hours, I'm going to have to go for minutes. So 1 hour is 60 minutes. And so now hours will cancel with hours, and I now have feet per minute. I'm almost there. I now need to get rid of minutes. So I need minutes on the top and seconds on the bottom. So I have 1 minute over 60 seconds. And notice that minutes now cancels with minutes. And now I have the right units. The only units I have left on the top are feet. The only units I have left on the bottom are seconds. Now, in order to do the math, basically what this is saying is take 60, multiply by 5,280, and then multiply by 1 and by 1, and obviously that doesn't change it. And then on the bottom, I have 1 times 60 times 60. So obviously you don't actually have to do the multiplication by 1. So I would just take 60 and multiply by 5,280, divide by 60 times 60. Now in this case I could actually cancel out the 60s, and so I really just have 5,280 divided by 60. If you do that on your calculator, what you're going to get is 88 feet per second. And so that would be our answer. you can do that conversion, you can do any conversion you need to be able to do. Let's look at one more example that sometimes trips up students, and that is you have to be particularly careful if you're converting area or volume. And let me show you an example of why that is. This problem says a cube has a volume of 4,322 centimeters cubed, and we want to know what the volume is in cubic inches. So we've got 4,322 centimeters cubed, and we want to end up with inches cubed. But here we have to be a little bit careful because the conversion we have is between centimeters and inches, not centimeters cubed and inches cubed. So the common mistake students make is they write 1 inch over 2.54 centimeters and they think they're done. But you'll notice we're not done because we only have centimeters, not centimeters cubed on the bottom. We actually have to apply that conversion 2 more times. So 1 inch divided by 2.54 centimeters and 1 inch divided by 2.54 centimeters. Now on the bottom we have centimeters times centimeters times centimeters, which gives us centimeters cubed, and so that will cancel the centimeters cubed we have. And on the top we have inches times inches times inches, which is inches cubed, which is what we want. If you do the math, in other words, you take 4,322 and divide by 2.54 times 2.54 times 2.54, you get 263.7 inches cubed. And that's the answer. Okay? So you'll notice that whenever we have area or volume, we have to watch out for this. Remember that area has units of distance squared. Volume has units of distance. I had a little trouble with my spun there. There we go. Distance cubed. So in either of those cases, you have to do this. Let's try another example. So here we have a problem that says an object has a mass density of 3.5 grams per centimeter cubed. What is the density in kilograms per meter cubed? So the first thing we have to do here is we have to figure out our conversion factors. You'll notice I didn't give them to you. And that's because these are just both metric prefix things. So in other words, I know that there are 1,000 grams in 1 kilogram because kilo means 1,000. Also, I know that centi means 100th. In other words, there are 100 centimeters in 1 meter. So those are the 2 conversion factors that I need to do the problem. So now I'm going to start out. I have 3.5 grams per centimeter cubed, and I want to end up with kilograms per meter cubed. So that's where I want to get to. And in order to do that, I'm going to have to convert both grams to kilograms and centimeters cubed to meters cubed. So let me start out by converting the grams to kilograms. I know I want to end up with kilograms on the top, and I want grams on the bottom. So that means 1 kilogram is 1,000 grams. And now I need to convert centimeters cubed into meters cubed. So I know that there are 100 centimeters per 1 meter. But I notice again that this is something having to do with volume, because what density is it's just mass per volume. So I've got to do that conversion 3 times because I have to get centimeters cubed to disappear and meters cubed to appear. So that way I've got centimeters, centimeters, and centimeters. So that would be centimeters cubed. That will cancel with the centimeters cubed there. Again, grams cancels with grams. And then you'll notice what I have left is kilograms on top and meters times meters times meters on the bottom, which is meters cubed. If we do the math here, we have 3.5 multiplied by 100 times 100 times 100 again, and then divide by 1,000. And if you do that yourself, you should get 3,500 kilograms per meter cubed. Or if we wanted to put that into scientific notation, 1, 2, 3, that would be 3.5 times 10 to the third kilogram meters per meters cubed. Let's take a look at temperature. There are 3 different temperature scales that are in common use, and Fahrenheit is probably the one that most of us are most familiar with, since that's still what we use in the US when we're just talking about how hot it is outside. But you're also probably familiar with Celsius as well. And then there's also the Kelvin scale, which you may or may not be familiar with. What this graphic shows is where are some common occurrences on each of those scales. So you'll notice we picked the 2 points of where water freezes and where water boils. And you can see that's in fact how the Celsius scale was set up. So it was set up in a way that makes a lot of sense. Water freezing is 0 degrees, water boiling is 100 degrees. Fahrenheit, water freezing is 32 degrees and water boiling is 212 degrees. On the Kelvin scale, water freezing is 273 and water boiling is 373. One of the things you'll notice here is that the Kelvin scale and the Celsius scale both have 100 degrees between water freezing and water boiling. So really the only difference between those two scales is where 0 is, but the size of each degree is the same. The Kelvin scale is set so that 0 is way down here, and we call that absolute 0 because that's actually the lowest possible temperature. We'll talk a little bit later about the fact that temperature is related to how much the molecules or atoms in a substance are moving, and absolute 0 corresponds to cooling something down so much that essentially all the molecular or atomic motion stops. Let's take a look at how to convert between these 3 different scales. We have 3 different formulas to do it. If I want to go from Celsius to Fahrenheit, this would be the formula to use. And if I want to go from Fahrenheit to Celsius, this would be the formula. Now I want to just show you that this second formula just comes from the first one because it's really just a little bit of algebra. In other words, if I want to solve for C, I have F is equal to 9/5 C plus 32. So as we know from our algebra review, the first thing I would do there is subtract 32 from both sides. So I'd get F minus 32 is equal to 9/5 times C. Now I would multiply both sides by 5 to get rid of that 5 on the right. So I'd have 5 times F minus 32 is equal to 9C. And then I could divide both sides by 9, and I would get 5/9 times F minus 32 is equal to C. And so that's where that formula comes from. And then finally, to go from Celsius to Kelvin, basically we take whatever the temperature is in Celsius and just add 273 degrees. So let's try these out. So here's an example. The temperature is 78 degrees Fahrenheit. What is the temperature in Celsius and in Kelvin? Well, to find the temperature in Celsius, I'm going to use this formula. The temperature in Celsius is 5/9 times the temperature in Fahrenheit minus 32. So let's see, that's 5/9 times 78 minus 32, and 78 minus 32 is 46, so I have 5/9 times 46, and so if I take that 46 and multiply by 5 and divide by 9, I get 25.6 degrees, and that would be in Celsius. Once I have the temperature in Celsius, to find the temperature in Kelvin, I just take the temperature in Celsius and add 273 degrees. So that would be 25.6 plus 273. And if you work that out, you'll get 298.6 degrees Kelvin.